I'm really want to thank everybody for staying. I know it's been a very long afternoon, but we do have one more section that we want to share with you, and that is our RDI Frontier Research Fellows. We awarded funding to 15 researchers across the Berkeley campus in January, and 5 of them will be joining us now to talk quickly for 1.5 minutes each about the research that they're doing. So please join me in welcoming our first guest.
Okay, hey everyone, I'm Vamsi. I'm going to be talking about some new threshold encryption schemes that we designed. This is based on joint work with my advisor and a bunch of other people. Okay, so if you've ever wanted to encrypt your data so that there's a committee and only if a majority agrees, then you get to decrypt. But you might have run into some problems. So the first thing is there's like this interactive setup that happens, and it's like really bad. You can't even scale past like maybe 30 people. So that's one issue. And another thing is it becomes really, really hard to change committees because whenever a party leaves, you kind of have to redo this interactive setup all over again. So if you face any of these problems, come talk to us because we have a cool new result called Silent Threshold Encryption Scheme. Silent means nobody has to talk at any point, no interaction needed whatsoever. You also get time lock encryption if you've used that in your startups. And it's concretely efficient. I promise I'm not one of those theoretical cryptographers. And it's also going to be useful in like decentralized auctions, MEV mitigation, and a lot more stuff. So do come talk to me.
Thank you.
Good afternoon. I'm Berkeley RDI, and I'm working alongside Ripple on the XRPL Zeki Bridge proposal and implementation. So you know the basic Zeki Bridge structure presented in the paper last year. It has mainly 2 components, the sender side and the receiving side of the chain. When it comes to the sender side, we have to generate a snark that proves the validation, like the light client verification. And then that's received on the updater contract. What problem do we have here? XRPL has no contracts. So how do we solve that? By treating header updates, the job that the smart contract does, as a transaction. So you'd have that as part of the consensus protocol, and the validators do the verification of the Zeki proof. So yeah, that's on the receiving side. And then what we've been working on these past weeks is on the sender side. We've been implementing the snark for verification of 35 SegP 256K1 signatures. Which is a bit of a problem because it's not ZKP friendly, but we've by using a recent paper called SnarkFold, we've been able to achieve really good results with a 10-second proof generation time, a negligible folding time, and constant proof size and verification time. So thank you very much for that.
So hi everyone, my name is Jun and I'm a PhD student from Berkeley Computer Science and RDI. I'm very happy today to share our work called Enhancing Smart Contract Security Analysis with Execution Property Graphs. Despite considerable efforts devoted to securing smart contracts, the community suffers severe attacks that lead to significant financial losses with about millions of dollars, even billions of dollars. So we propose our approach that by constructing the execution property graph for better security analysis. The graph includes the information of dynamic execution of the smart contracts, and about the data flow, control flow, asset flow information, and change the raw data to a more programmable and human-readable graph representation. With the help of the graph representation, we can perform graph traversal analysis, better manual inspections, post-mortem analysis, and vulnerability detection, and much more. On our experiment on history attack analysis, we adapt the solution to various attacks, and we can achieve high accuracy. Also, we discover some zero-day vulnerability. Thank you very much.
I come from a slightly different perspective and background. So I'm a first-year law student, and my research is really in the intersection of blockchain, Web3, and law. Very honored to be among this panel of very technical people. I think this goes to show how RDIs and the fund is willing to extend to really the intersection of blockchain with many different industries. So I'm trying to bridge this gap between what we see in Web3 and crypto and how tokenomics and issuing tokens is such a big part of everything that we do. And on the other hand, we have this list of regulators that's really trying to wrap their head around understanding, right now this is a security, but also wrapping its head around how to regulate that when it comes to insider trading. So the insider trading crypto space is unlike traditional stock market where you get a tip of a stock and then you. Oh, thank you. Thank you. It's unlike traditional stock markets where it's highly regulated, and we've seen some of that in the Coinbase insider trading case where an employee gets a information tip and then use that to trade. But what I see from my experience working in the industry is that a lot of insider trading and unfair practice happen more at a background, at an institutional level. I don't know if any of y'all here has worked with market makers, and some of them would promise that they would draw you any chart you would like to see. So I'm really trying to understand the space better and help regulators understand this space better. So if you have any tips, if you have experience you're willing to share, under research ethical guidelines, happy to chat after this conference. Thank you.
So hello everyone, this is Xiaoyuan, and today I'm going to introduce another DeepIn project focusing on decentralized LLM inference, and I'm very happy to see actually today many companies are working on the same problem. So just for the background, with the growing need for the inference, many companies actually nowadays start to provide open source model inference services. And our project is aiming to solve the two key problems in the open model serving. So first, we want to solve the performance problem, which means that we want to see how fast we can get for the model to output to output the tokens. And also we want to increase the capacity for a given infrastructure. And second, we want to build a fair and secure on-chain settlement protocol that instead of buying credit card to, let's just say, AWS or something, that you can actually pay with cryptocurrency. In the meantime, the GPU miner can get corresponding incentives. And early stage results suggest that performance-wise, we can achieve human reading speed, sort of generation speed, that on an unquantized original model, that is largest model of Llama with 70 billion parameter with 8 consumer level GPU. And also we design an end-to-end protocol to amortize the cost by introducing off-chain signature exchange. And if you're interested, please consider joining the Slack. And also, if you know friends who need inference service recently, we're actually currently doing beta tests. So if you join there, you all see that we already have the web service there for you. Thank you.